I just discovered a shorting risk using this BCR port. So one of the pins on this is directly connected to the 5-volt rail inside, and another is ground, and another is a signal in. There's actually two grounds. One's a signal ground and a power ground. They're actually connected. They're the same inside. It's just one has a thinner trace going to it. One has a thicker trace. So the power, one ground has a thick trace that's the same as the power trace, and then there is a signal, an input line, which is reading the BCR TTL level BCR data. So I went to pains making this little adapter to arrange it such that it's all small and fit, and the plug pointed in a sensible direction, and yet the 5-volt pin was not exposed anywhere, and so there's not a shorting risk. So on this, the only place that's even remotely exposed is right there. That square with the plus next to it is 5 volts. All right, so it's kind of near other things that are ground, but you can't really get anything in there to short it. It's pretty well covered up just by the fact of just by where it is, and that's the worst thing. There's the other places where the 5-volt pin exists on here are they're underneath. They're underneath here. They're trapped underneath this USB plug. They're not near this edge where this edge might touch it, right? The back sides of these pins right here, these are all okay. None of these are 5-volt. They're all okay to be shorted. They're either already ground, or they're the signal input, which is okay to touch the ground. And the 5-volt pin is somewhere around here, but covered up by the base of the USB plug, which is plastic. And even the part that's not plastic is, the shield is metal, but it's elevated far above the PCB. It's not even at risk of touching anything. But the power pin is just about at the edge of that plastic base. It's kind of half in and half out of it, and nothing's touching that power pin. Nothing's ever going to short it. Like when you plug, a USB plug, it's metal. It's all metal shield. And get the focus again. When you go to touch here, it's going to touch those exposed pins. So I made sure that would be fine to do. There's nothing there that you have to worry about. It's okay to do that. So I do all that, and I get that good. And it turns out that there's still a problem you have to watch out for. The outer shield of this is metal, and it's rounded, and it's very easy for that edge right there to touch those pins. And so just by having this anywhere in this vicinity, if you're, when you're just inserting it normally, if you're just a little bit crooked and you go like that, boom. And so luckily it seems like a brief touch, doesn't do any permanent damage, but if you touch it, where am I? Kablooey. Scrambled my screen. So I have to power cycle to get back. I don't know how many times I can do that and have it still live, so I'm going to stop doing it now, but I discovered my screen was scrambled and I didn't know how it got that way, and this was how. So there is a pretty good answer for this. There is see. There's a pretty good answer for this. It's just a little expensive. There is an alternative 9-pin plug you can use. Excuse me. Okay. Needed both hands to open these bags. There's an alternative 9-pin plug you can use. And from DigiKey, you can get from DigiKey, which is all plastic, which is an all plastic body. And so I was originally using one of these. Problem is, this normal metal plug is, 40 cents or something, and this is like something like $4. It's ridiculous. It's more than $1. I don't remember exactly what it was. I think it was multiple dollars. I think it was like $4 per plug. So if you're only going to make one of these, I guess it doesn't matter, but it still is kind of crazy to have $4 for this connector. However, you can buy it new still, right off the DigiKey, no hunting down weird old stuff that you can't, from eBay or something. And it's all black. And it's perfectly safe, I originally had one of these just because I liked the idea that it was black plastic and it matched the other black plastic, and plus it was, plastic's lighter weight, everything to do with the mobile. I like to think lighter weight options. Even though for something this tiny you don't think it matters, but if every single thing is made this way, it adds up to matter. So anyways, you can get this. What's the part number? There's the part number, A34005. From DigiKey. Maybe I'll change the directions on the GitHub and on OSH Park to specify this. And then the next thing you do with this is you can cut. You don't have to leave it this full size, or you can. It doesn't matter. I like to actually cut it. You just cut this right about. You can just grab it with the side cutters, with your wire cutters. You just crunch it. The plastic breaks apart pretty easy. You just cut it right about there, and right about there, and that makes it small enough. Oh yeah, you do have to cut it anyways, because you need to cut it down so that it's cut down to about here, because you have to expose this little edge of the PCB so that you can solder the USB connections. And I have one that I did like that on an earlier version of the PCB. Let's see if I can still find it. Okay, it's an earlier version of the PCB where I did that. This PCB is larger than necessary, but it was easy to solder. So this PCB, when you solder it, you don't have to crimp over the little shield tabs on the USB plug. The way this one works is the footprint, the holes, those shield tabs, they press into that hole and they provide a little resistance. They kind of hold themselves in place, and you just solder it like that. On this other one, on this updated version, I made the PCB smaller, and it's not holes on the out, it's like a little half circle on the outside edge, and you're supposed to crimp those little USB, those little tabs on the shield of the USB, crimp them over so they clamp down onto the PCB, and solder it that way. And then the end result is just, it's all a bit smaller. It's just a little smaller and neater looking. But this is also perfectly fine. This was like the first version, and you know, this was easy to solder. But you see, I cut the thing down. I cut the plastic down small enough, short enough, just the right shortness to expose these 4 USB pins so that you can solder them. You have to solder the 9-pin first, because the USB plug covers up most of the 9-pin pins. So you have to solder the 9-pin first, cut them all flush, then put the USB plug in place, flip it over, and then solder the USB plug. You can't solder that USB plug if this thing was larger and it was covering up those pins. So, and that was effortless to cut that. It just cut with the, you know, it's not tough. You know, when you grab it, you can just grab it with your angle cutters, your flush cutters, wire cutters, which aren't all that strong. It just kind of crumbles and breaks apart pretty easy. And then I just sanded it. I just took the after I cut it, I just sanded it on a sandpaper on a board just to make a, you know, cleaner looking surface. And then this this has no shorting, no short. Come on, focus. No short risk, because it's all plastic housing. You know, just like the female plug that's in there. So I may change the directions to specify that part explicitly, just for that reason, because I would really hate for people to fry their computer because of something I told them or gave them. But these plastic connectors are definitely less common and cost more. You'd think they would cost less being all plastic, but I guess just because they're less common, that makes them cost more now. So that's that. That's the full one before cutting it. PCB is no different. Like, you could just use this connector on this PCB. It's no different. So I'm not going to have to change the PCB design at all. The only thing I might do, well, maybe I'll change the PCB design, only the silk screen, just to specify this part number instead of this part number, but it doesn't really matter. You know, it would just be for reference. That's unfortunate. All right.